Hey there, cats and kittens. Today we're going to look at what actually makes these beast inverses and such. Alright. Yeah, pre-calc people, we are looking at 2.10a. We're going to do examples, a few. This is a lot of setup for why we're doing what we're doing. And I've talked about this a lot in class. What are logs? Logs are inverses of exponentials, right? And we can flip our domain and range. The graphs are reflected. Let's actually do an exploration of that today. All right, so we're going to graph y equals b of x, y equals log base b of x, and y equals x. Well, y equals x is pretty easy. Boom. So they pay me the big bucks, right? Now, to graph the other ones, let's try a basic function, basic exponential. Let's do 2 to the x, right? So 2 to the negative 2 would be 1 over 2 squared, which is 1 over 4, right? 2 to the negative 1 is just 1 over 2 because a negative exponent flips it. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. So when I graph this, I have negative 2 a quarter, negative 1 up a little more, 0, 1, right? It's my intercept. 1, 2. Yeah, you guys know what exponential kind of looks like. It's going to be... I didn't hit any of the lines, but that's okay because I'm doing my best. So this is my basic b to the x. Now I'm going to take these points and plug them in for x. Okay, I'm doing my f of whatever dealio. So I'm going to take these points and plug them into my log base b of x. Because then when I go to draw the graph, it's going to be a lot easier because I'm switching my x and my y. You know what I mean? Because what's log base 2 of x equals a fourth? 2 to what power equals 1/4? Well, negative 2. 2 to what power equals a half? Well, negative 1. 2 to what power equals 1? 0. See, they're inverses. 2 to what power equals 2? 1. 2 to what power equals 4? 2. So if I do my, we're pretty much doing f inverse of x, right? And you should get x. Let's graph and see what that looks like. So I have the points 1/4 and negative 2. Should be about here. Negative, or a half, negative 1, which should be about here. And then I have the point 1, 0. No way. It's an exponential going the other way. We talked about that, right? So there's proof that it works. Not going to do a whole lot, but I just want you to notice that it's your f of f inverse of x. So what is a log? It is the inverse of an exponential. All right, let's take a look at this beast. So let's analyze that graph up above, right? So I'm going to redraw it, maybe a little bit better. So, you know, I had my, what was it, 1/4 negative 2, right? Oh, that'd be here. Half 1, 1, 0, right? 2, 1, 4, 2. If you want to get really technical, it'd be 8, 3, 16, 4. Because 2 to the 4th is 16, right? So if I draw this in, this is a lot harder on Mobi than in real life. That's a pretty good graph, right? So my domain on this, can I ever go to the left of my y-axis? No. Do I ever reach 0? No. So my domain is from 0 to infinity. Now for my range, for my range, I do go down forever and I do go up forever, just really slow. So my range is from negative infinity to infinity. Again, those are flipped around because remember our domain and range of our exponential was negative infinity to infinity was our domain, and from 0 to infinity was our range. So we just flip those because it's the inverse. So now what's my limit of f of x as I go to infinity? So as I go to the right, I will keep going up to infinity, right? As I go to infinity. Now, what happens as I approach 0 from the positive, from the right side? Well, I'm going to go down to negative infinity. Okay? It's getting kind of messy. Messy, messy, messy. Good old Frosty Snowman reference. The magician. You know what I'm talking about? You know what I'm talking about? All right. What's my asymptotes? Do I have one? They're a pain in the... Never mind. All right. You do. You have a vertical asymptote at x equals 0, right? Do I have intercepts? Yeah. I have an intercept at 1, 0, right? And that would be a, what, good old-fashioned x-intercept. I don't have a y because I never crossed y-axis. And concavity, well, when you look at it, it is always down. It's concave down. All right? Because it's curved like that. The bear can't live there, it'd fall out. Okay? Okay. We got one more to look at. Compare and contrast. And do this analysis. What's going to happen if we take our b and we put it between 0 and 1? So remember, we're changing this into a decay function. The other one was a growth, right? Because b was greater than 1. If b is in between 0 and 1, it becomes a decay. So it changes it a little bit, right? It'll change its direction, so let's say. Because it's going to go down over time. So let's make b a half. So a half to what power equals 4? Alright. Oops. You guys don't need that. So now we changed it to decay. Sorry, I got distracted for a second, so there'll be some wildness here. So, let's graph it. Well, I know it's going to pass through the point 0, 1 because all exponentials pass through the point, or I'm sorry, 1, 0, because all exponentials pass through the point 0, 1, and it's an inverse. So I switch my x and my y. So now what I got to think about is when I plug in 2, what's 1/2 squared? Right? I'm sorry. When I plug in 2, 1/2 to what power equals 2? Well, -1, right? Because I got to plug in those negatives to flip it. For 4, I'm going to skip 1/2 to what power equals 4? Well, that's -2. 8's going to be -3. 16 is going to be -4. It's kind of like what we did before. It's like a rotation. And then this one's just going to shoot off. Let's see how I can do. Reap, reap. Not bad for a government employee. So now, my domain's the same as the growth, right? Or the inverse of a growth. It's going to be from 0 to infinity. And I don't cross 0. My range is going to be the same, from negative infinity to infinity. My limit as x goes to infinity will change. So as I go to the right, my function will keep going down to negative infinity, slowly but surely. My limit as I approach 0 from the positive side is going to be infinity. My asymptotes are at, again, it's still x equals 0. That's not going to change. I have a vertical asymptote. All that's really changing is going to be my end behavior and my concavity. So my intercept is still at 1, 0. and that's a good old-fashioned x-intercept, no y-intercept, of course. Concavity of this one is up, right? It's up, not down. I don't know. That should give us a good start for tomorrow. Hope you learned something. Make good choices, be good people.